SFRC Online.
In this segment, we'll be discussing basic GPS setup and operation. Before setting up any instrument, it is a good idea to make sure that it is in a sturdy platform. By doing this, I'll check the legs. I can see that the legs are planted firmly in the ground. Next, I will check to make sure that the tri-rock is level. I do this by examining the level bubble on the tri-rock. I can see that the bubble is squarely inside the circle on top of the tri-rock. This indicates that my tri-rock is level. Next, I want to make sure that the tri-rock is centered over this control point on the ground. To do this, I will look through the optical plummet. I can see that the tri-rock is centered over the control point. This means that I have sufficient setup to put my GPS receiver on. The geodetic grade GPS receiver that we will be using for this demonstration is a Topcon Hyperlite Plus. It has a built-in antenna, radio, memory, and receiver. I will now attach the GPS receiver to the tri-rock adapter. I will spin it on, making sure not to drop it. So always use two hands. Then I will tighten the screw on the tri-rock adapter to lock it in place. You have now set up the GPS receiver for data collection. A GPS receiver receives signals at the antenna phase centers. For this receiver, we have two frequencies that it acquires, the L1 and L2 frequencies. Thus, the GPS receiver calculates the position of the antenna phase centers. Unfortunately, we want to get the point on the ground. To do this, we must measure the difference between the ground and the antenna height. There are two methods for measuring the antenna height: the vertical method and the slant height measure method. The first method, the vertical height, is getting the distance from the control point to the antenna reference point. On this receiver, the antenna reference point is the point at which the receiver meets the tri-rock adapter, right at the bottom of the receiver. To do this, I will take the tape measure and I will measure from the control point and estimate the distance to the antenna reference point. When doing this, I want to record the measurements in both feet and meters. This will help to avoid transposition errors back at the office. This is just an estimate, however, as you have to eyeball the antenna reference point. The second method is a slant height measure method. To do this, you must measure to the slant height measure marker, which is indicated by the yellow triangle on the front and on the back of the receiver. It is not the actual yellow triangle, but the edge right here below that. To do this, I will take my tape measure and I will put it on the ground by the control point. I will then measure to the edge. I will record my measurements in feet and meters again, and also take care to mark the method that I use in my field notes. This is the proper way to measure your antenna height. In your field box, you may find this card. It indicates the offsets between the two measurement methods, between the slant height measure marker and the antenna reference point. You do not need to record these values in your field notes unless you'd prefer to do the math yourself. The post-processing software will do the math for you. Before starting your GPS survey, you must become acquainted with the minimal interface of this receiver, also known as Minter for short. As you can see, there are 3 buttons, 4 LEDs, and 4 serial ports. When you bring the receiver out of the box for the first time, you will be performing what is called a cold start. Right now, the receiver is currently in 0 power mode. To turn the receiver on, you will press the reset button for 1 second and release. You will start to see some of the LEDs flashing. Do not be alarmed. This is normal. When you perform a cold start, you will notice that the status light may appear red for a long period of time, perhaps 45 seconds to 1 minute. If it stays red for a longer period than that without seeing any green or orange flashes, this means that you are not receiving any satellite data whatsoever. The 3 buttons, the reset button was used to turn the receiver on from 0 power mode. The power button is the green button up in the upper left-hand corner. This is used to turn the power on and off when the receiver is on. It is also used to restart the receiver when the receiver is in the sleep mode. The function button is the gray button just below the power button. It is used to start recording data. Now, the LEDs. In the upper right-hand corner is the battery LED. This will blink green when there is a 85% to 100% charge of the internal battery. From 15% to 85%, it'll blink orange. Less than 15% means that it'll be blinking red. At this point, you may want to bring your receiver back to the office and charge it up. You may not have enough battery life left to continue your survey. The LED just below the battery LED is the RX LED. This is the communication signal LED. I will discuss this in further detail later. The next LED is the record LED. This indicates whether data is being logged to the receiver. Finally, the status LED is the top LED. It blinks for each satellite that is being tracked. The green blinks indicate GPS satellites. The red blinks indicate GLONASS satellites. As you can see, 2 GLONASS, 1, 2, 3, 4, 5, 6 GPS satellites. You should now understand the fundamentals of basic GPS setup and operation. At this point, you will want to power down your receiver to the 0 power mode. To do this, you will hold down the power button for 8 seconds. At this point, it'll flash double green. At 4 seconds, it'll flash double orange, and then it'll flash double red. At this point, release the button and you are put in a 0 power mode. To indicate that you're in 0 power mode, the battery LED will be turned off. Also, when you press any of the buttons, i.e. the power button, it will not turn on the receiver. You have successfully turned off the receiver and put it in 0 power mode. Now please go to the office and download your data. Also, make sure that you properly store your receiver and bring it back to the office.